Hello. So today I'll be doing a hopefully short Fusion 360 tutorial. This will be relatively, simple, beginner friendly, because, I've been using Fusion for a couple of years now, on and off, and I recently got a lot more into it, a lot more familiar with the workflow, and I just wanted to kind of share, my experience with it, and kind of if you're interested, to give you kind of a rundown of the basics. Obviously I can't cover everything, but I'm going to try to cover enough to get you started if you're interested in the software. And I'm going to assume you have little to no experience with CAD software. So this is the example part that I made for this video. I didn't want to make one completely from scratch because there's a lot of stopping, starting in when I do that, I'll get stuck here and there and have to kind of troubleshoot. That's always been a normal process for me, and I think for most people. But I'll take you through each part of the process that I did to accomplish this. So Fusion 360 is a CAD modeling software. So unlike Blender, which is based on polygons and meshes, this is based on math and shapes and measurements and relative measurements. And, um, it's designed for precision and accuracy. So we're not dealing with polygons at all. We're just dealing with shapes and lines and measurements and how all of those things are interrelated, and steps that are taken to gradually build out the model piece by piece. So this is my finished model that I made, and I'll show you that I have in my parameters here, I have two user parameters, which is my width and my length. So I can change this width, let's say, to, instead of 125 millimeters, I'm going to change it to 85 millimeters. And now my model auto updates, the holes auto update, the spacing of these supports auto update. Similarly with my length, if I change this to, let's say, 90, it will scale everything accordingly. So that I wanted to make something parametric like that based on parameters to kind of show the capabilities of that kind of way of building a part, because it's one of the big strengths of this kind of workflow where all the steps of the process are maintained in this case, it's, I think, the timeline, or I'm not sure what this bar at the bottom is called, but so you can always go back and modify a previous step, and it will recalculate all the subsequent steps in the process. So every CAD or Fusion model starts with a sketch. So I pulled the timeline back here to this sketch. It's currently hidden because it auto hides sketches, but I'll just unhide it here. And I will right click, edit sketch to go back into it and see what's been done here. So I've drawn a rectangle, and then I've drawn two cross lines through from corner to corner on the rectangle. I've made both of these equal to one another. And I have defined the width and the height using my parameter here. So if I go into my model parameters, and I have under my sketch 1 here, I have my linear dimension 2 and 3. In my expression, which is where the value would be normally, I've defined max, which is, so this is a function which takes, it essentially gives you whatever the maximum of these two values is. So if my length is more than 75 millimeters, it will take that. If it's less than 75 millimeters, it'll just take the 75 millimeters. I added this so that it's not possible to make something too small. Essentially, if it becomes too small, it bottoms out at 75 millimeters. So if I change these values to something less than these two values that I put in, it'll just take the higher one that I've defined. So that's why these two values have fx in front of them for function, because it's using the function that I've defined. So just to show you how, sorry about that, just to show you how something like this is done from scratch, I'll make a new rectangle over here. So when you first draw a rectangle or any shape, a line or anything, the sketch will be blue, most likely, because it won't be fully defined. When any line is blue, it means that it can still be moved around and modified because it's not fully defined. In this case, my lines, because when you draw a rectangle, it auto constrains these edges to be vertical and horizontal. They each have this little icon, which when you click on it at the bottom right here, it shows you there's a vertical constraint. If I click on this one, it shows horizontal constraint. So these lines will always be horizontal and vertical. If I delete one of them, for example, if I just selected it and hit the delete key, now if I move it around, that line can change angles. So when you're making a sketch, you want to fully define the sketch such that ideally all the lines become black and none of them can be modified. That will ensure that any subsequent steps you make, that sketch won't change, and so your model is predictable in how it's being built out. These cross lines I made, I drew them like a regular line, just like this. But then you select it, right click, and hit normal construction, which makes it a dotted line. This just makes it, when you're extruding, for example, it doesn't consider this to be a line that's dividing the shape. It's just used for constructing relationships or other things of that nature. So I made these two lines going from corner to corner. As you can see here on this point, there's two coincident constraints. So this corner is coincident with this line end. That's why there's two. If I undo these, this so this is the danger of having a not fully constrained sketch, is that inadvertently you can potentially move something, and then even though you have all these other constraints, you have one element that's not constrained, it can totally mess up your sketch. So you want as much as possible to have your sketch fully constrained in that case. So once I fully constrained this sketch, I then finished sketch and moved on to extruding it. So I added an extrude, and then select it. In case it wasn't already selected, you select that face. And then when you actually make the feature, it gives you this dialog box. It gives you this little gizmo and this little input for your distance. So in this case, I just put in 5 millimeters. You can define where the extrude starts from. If you want it to start on the plane that you're drawing your sketch on. If you want to define an offset, so a distance offset from the plane you're drawing on. Oh yeah, I should have specified when you create a sketch, you must select a plane on which to draw that sketch. All your sketches need to be on a flat plane for the most part. I think there is an option to make a 3D sketch, but that's beyond the scope of this video. And there's I would say, few cases where you need to do that unless your part's really complex. So I've extruded this face outward by 5 millimeters. I'm just going to hit OK because I've already done that. So in this case, it's extruding, we're looking at the bottom now, so it's extruded upwards by 5 millimeters. Then I went ahead and made another sketch, which in this case, I made a box on the right plane, so perpendicular to my extrusion. And I then, I selected this edge, and I went into create, or sorry, yes, create, sorry, I have to go into edit sketch. And I selected this edge of my extrusion and went create projection and project. And then I hit OK. It's already projected, so it's not going to allow me to do that again. But essentially what that does is it then takes a reference to that edge and projects it onto my sketch plane, which I can then use and relate to my other sketch lines. So what that means is, in this case, I made this line equal to this line, or rather the other way around, this line equal to this line. The equal constraint works both ways. So it makes both lines equal to each other. So that allowed me to constrain it along the width of this rectangle. I then made the height of this rectangle equal to d1 over 5. So d1, in this case, if I go into parameters, I can look at the name. d1 is my linear dimension 2 in my first sketch, which is basically my length. So this is the length of my extruded rectangle divided by 5. So you can use measurements like that to give other measurements either the same value or new values using math. So this height of this rectangle is defined by the length of this first rectangle I made. So once I've done that and made sure it's fully constrained, so in this case, the top right of this rectangle is coincident with this line here. I then finished my sketch, made sure all the lines are black, which means they're fully constrained. And I then made another extrusion. Now this extrusion, I made it a two-side extrusion to go to both ends from the middle section. So the first side I went to object, and the object it's going to is this outer face. And then again on the other side to object, and then I selected that outer face. So once again, now that width of that extrusion is being defined by those outer faces of that extruded rectangle, such that if I change the first rectangle, those will update automatically because they're dependent on it. So just to give you a visual example of that, once again, if I go into here and I change this to 105, my width changes and my extrusions automatically update. And again, if I now change my length to 100, let's say, that lower, the height of that other rectangle will update slightly. It wasn't that visible there because I didn't change that much, but the measurement updates because it is dependent on that value. So moving on to the next feature, I added another sketch on the same plane, and now I made a triangle, I used my other sketch. Just want to make sure that yes, okay. I just saw that little icon there. It was showing that I had a projection line. Yeah, okay. So I have this triangle that I made at this point coincide with this other sketch that I made. I then, let me just, oh, that's why I'm not in edit sketch. Okay, there we go. So I have this angle defined. I did that using the sketch dimension. This is the tool to define measurements and angles and everything, basically any interrelationship between lines. So I've defined 45 degrees between these two lines by selecting this and clicking on both lines. And then it gives you the current angle. You can just hit enter to accept it, or you can input the value you like. And then similarly, I selected this outer edge and defined it as being D5 minus 5. And if I go into my parameters, D5 is the line on my previous sketch, the one right before this. So it's the height of this minus 5 millimeters. And as you can see, D5 is D1 divided by 5. So again, you can have this codependency of values throughout your model such that they're each interrelated with different different operations being done on them. So again, once the sketch was fully defined, I moved on to another extrusion. In this case, I did an offset starting point. So I offset it by the value D2, which in this case was my width dimension, divided by 4. So a quarter of the width of the entire thing. I then made the extrusion symmetric such that, so I'll just show you by doing this. This is the half length and this is the whole length. As you can see, when I switch back and forth, the middle point is kind of where my offset is going to, essentially. So the offset by this value is going to about the midpoint here, and then it's extruding 5 millimeters from that center point. So the width of it is 5 millimeters centered on my offset. I then created a pattern, a rectangular pattern. And when you do this, you have to select the object type. So in this case, I selected the feature. I selected my extrusion. I then selected the axis that I wanted the pattern to run along. So in this case, the x-axis. From the origin point, the axes are visible on the origin point. And then the distribution I made along an extent. So you can define it as the entire extent of the pattern or as the space, the individual space between objects. In this case, extent was fine. I made 3, and I defined the distance as D12, which was my offset. So the offset that I used to move the extrusion over times 2. So 1, 2. I could have also instead just done the offset and then made that spacing, I believe. That didn't work the way I expected, so I'm just going to cancel that. Let's just try that again. Spacing, distance. Yes. Okay, so you can do it across multiple axes. I'm just using the first axis because I only want to see a pattern along this way. I don't need it to go like I don't need to have a rectangular pattern. I just want a linear pattern. So I define the distance as d12, which is the offset from the center. Okay, so I then made the next sketch, which is my holes. So to do this, I'm just going to hide the actual body so that you can see kind of what I ended up using in my sketch plane. I'll hide these other sketches too. So what I ended up doing was I selected this face, which was not including these holes. So I selected this face and I did a project to get the edges of all these faces in my sketch layer. So when I did that, I made these crosses here to get where the center of my circle will be. I then drew the circles, made their center coincident with both of the lines, which forces it to meet where both lines meet. I made both lines equal, and I made their points coincide with the corners of this sketch. I made all the circles equal so that I only needed to define the width of one of them, or the diameter of one of them, so that if I change this diameter, they all update automatically. Once that was completed, I then let me just hide the body. I then made an extrusion with the operation cut. So instead of adding, it's subtracting the extrusion from the body. I made it start from the profile plane, go to one side. I made sure the side was flipped the correct way, because sometimes it's extruding the incorrect direction. You can flip it so that it is cutting through the right direction. I just made it go through all. You could also have it extend just to the back face, but in this case, there's nothing else I need to worry about it cutting through. So once that was completed, then I moved on to my kind of finishing elements, so my chamfers and my bevels. So here I added a chamfer, which I've selected the 4 edges around the circles here, and then I applied a 2mm chamfer. You can add more edges. You can add, a variety of edges with different chamfer sizes in this feature, but that's all I needed to do for now. I then added some bevels on these corners. Again, selecting the corners like this, and then hitting the fillet or bevel, whichever you prefer to call it, to add that feature. And finally, another bevel. I could have done this actually in the same one here, so let's just do that. I'm gonna edit this feature just to show you what it's like. I'm gonna add a selection set. Nope, that's not what I wanted to do. Let me just try again. Edit feature. Added selections. Okay, I guess that is what I wanted to do. So I'm gonna click on these lines here. And now I can either write in the value or just drag this gizmo till I get what I want. I think I want about a 4. Let's add a maybe a 4.5. No, let's also make it 5. So in this case, I could actually remove this one and just thought there would be a way to add edges to this selection set, but I guess not. So I'll just do like what I did, add, make that 5. And there you go. So now I have my part completed. I guess the final thing I should touch on is these user parameters. I added those. You could just write in, you don't have to add user parameters, but I wanted this to be kind of the only thing that I needed to change. I added those by hitting this plus button that adds a user parameter. You can then add in a name, whatever you want, and then you can use that name as a value in other expressions of variables. You can also use whatever measurements you've done. As I said, you can use those names that are auto-generated or rename them yourself in other expressions. So that's how I was able to make this such that now you can modify these values and have things auto update. So as you can see, if I go down to 42, for example, it still works. Even if I go to 1, it's going to stay here because I've established my minimum. It's a bit confusing because I have the max expression, but as I said, it's taking the maximum value of the two. So in this case, it's taking 80 millimeters. So I can go 85, it should get a little bigger. But if I go below 80, it doesn't go below 80. So I think that's about it. If you have any questions, feel free to leave a comment. And if you like this video, let me know. Thanks. See you later.